In this video, we're going to talk about how we can graph linear equations using their intercepts. And what I want to first start with is actually defining what an intercept is. All right. The first one I want to look at is what I call an X-intercept. All right, and the X-intercept is basically a point where a graph crosses the x-axis. And remember, your x-axis is your horizontal axis, going left to right, right? So I want to know what point, when I want to know what point does my graph cross my x-axis, that is what I'm going to call my X-intercept. And likewise, for a Y-intercept, it's the point where our graph of the line that we're going to be drawing crosses our y-axis. All right, and remember, your y-axis is your vertical up and down axis. All right, and so I have an example here where we look at the graph of a line. I don't give you what the line is. We're just going to look at this graph in order to help us find out what the x and the y-intercept are. Okay, and so if I look at this graph, the scale on this graph, this is my x-axis here, this is my y-axis here, and the scale of my graph is by ones, right? And so if I want to look at my x-intercept, I'm going to abbreviate X-I-N-T, then I want to look at basically the point where my graph crosses my x-axis, which is this point right here. And that point, as an ordered pair, will be the point 1, 2, 3, 4, 5, 6, 0. So my x-intercept is the point 6, 0, because from my origin, I go to the right 6, and I don't go up and down, all right? Now I'm going to find my y-intercept. Remember, your y-intercept is where your graph crosses the y-axis, and so crosses my y-axis at this point right here. And if I get that ordered pair, it's going to have a x-coordinate of 0, and my y-coordinate is going to be 1, 2, 3, 4, 5, 6, 7. So I'm going to have a y-intercept at the point 0, 7. So these are my x and my y-intercepts. I wanted to go through this because there are two main things that always happens with x-intercepts and y-intercepts. All right. For x-intercepts, since it is the place where it crosses your x-axis, and this is your x-axis, every time we have an x-intercept, it's going to have a y-coordinate of 0. That is always going to happen because it is on the x-axis, meaning we don't go up or down from our origin. We just go right and left to get points that are on our x-axis, all right? The same thing happens when we look at our y-intercept, all right? Well, something similar, not exactly the same. Notice that here I have x equals 0, all right? This is always going to be true because when I look at my y-axis, notice from our origin, we don't go right or left. We only go up and down. So our x-coordinate is always going to be 0. And so what this does is gives us a way to find our x-intercept and our y-intercept. And I wrote down some steps here, but it basically explains why, uses what we just found out. So to find our x-intercept, using an algebraic equation, what we're going to do is we're going to set our y equal to 0, and then we're going to solve for x. All right, and that'll give me the x-coordinate of our x-intercept. Likewise, to find our y-intercept, we're going to set x equal to 0 and then solve for y. All right, let's look at an x and y-intercepts, and then we graph equation of a line. All right, this example here, 5x plus 2y equals 20. What I'm going to do is I'm going to start by finding my x-intercept. All right, to find the x-intercept, we just went over that we have to set y equal to 0 and solve for x. Right, so I'm going to set y equal to 0, so I'm going to replace y with 0. All right, of course, 2 times 0 is just 2, so this is going to be 5x equals 20. Right, and this equation, all we have to do is divide both sides by 5, and we'll be able to solve for x. So we get x equals 4. And so as an ordered pair, we have an x-coordinate of 4 and our y-coordinate. Remember, we said with the x-intercept, our y is always 0. And so we get the point 4, 0. Now I'm going to find my y-intercept. And I'm going to abbreviate intercept with int. This time we set x equal to 0, and then we solve for y. Well, of course, 5 times 0 is just 0, so I get 2y equals 20. And if I divide both sides by 2, I can isolate the y. We get y equals 10. And so our x-coordinate, remember, we let x be 0 here. Right, so that's my x is 0, and my y-coordinate is 10. And so for me to graph this equation here using my x and y intercepts, all I have to do is plot both of these points here. So I'm going to plot this point first. It's the point 4, 0. So from my origin, I go to the right 4 and don't go up and down, up or down. That's my x-intercept. And to plot the point 0, 10, go to 10 on your y-axis, and you have your y-intercept. And so you have your 2 points now. And so all you have to do is to connect those 2 points with a smooth line. All right. And so I have my equation drawn. All right. This is what happens when we graph by finding our X and Y intercept. All right, so that's our second method of graphing. In the last section, we talked about graphing by plotting points. This is our second method, and we'll have one more method that we'll use to help us graph an equation of a line. All right, what I want to do now is talk about lines that are a little bit different. All right, I want to talk about equations of lines that are horizontal and equation of lines that are vertical. All right, horizontal lines, they always come in the form, all right, and this says any line that can be written in the form y equals b, all right. B is going to be some number. Notice that there is no x in this equation here, all right. It's just y equals some number, and I'm just saying b, all right. That tells us that we're going to have a horizontal line. So anytime we have y equaling to some number, we have a horizontal line. And the reason why we have a horizontal line, because y is stuck, all right? So if I look at a graph, y is the only thing that does not change. Your x's change. And so, like, if I look at the graph here, and if I say I have y equals -4, well, when I draw the line, every coordinate on that line has to have a y value of -4, right? And so since that happens only for a horizontal line, that's why it has this form right here, y equals some number. The same thing happens for vertical lines. The only difference is it's going to be any line that can be written in the form x equals a, and I'm letting a be some real number, all right? So whenever x equals a number, we have a vertical line. And in this case, notice you don't have the variable y when you're talking about vertical lines, all right? And so what I want to do is look at two examples of graphing horizontal and vertical lines, intercepts. All right, let's look at this example here. I have the line y equals 8, y equals 8. And I want to graph that line. Well, we just went over that when y equals some number, we have a horizontal line, right? Because our y value is stuck being just 8. So every point on that line has a y coordinate of 8. That means if I find 8 on my y-axis, all I have to do is draw a horizontal line. Okay. And now if I look at this line, I want to also label my intercepts. Well, I only have a y-intercept, and that's the point 0, 8. All right, so if I think about my y-intercept, it's where it crosses the y-axis, 0, 8. If you notice, it is the same thing as what you see given into your equation. And if I try to think about my x-intercept, remember, x-intercept is where it crosses the x-axis. There is no x-intercept here. All right, so horizontal lines don't have x-intercepts. Let's look at another example of graphing a horizontal or a vertical line. In this example, we have x equals -2. All right, again, when I have x equaling some number, it is going to be a vertical line, right? And so I'm going to find where x equals -2 on my x-axis, which is right here. And that is the only x coordinate that all of the points on that line is going to have. So that makes it a vertical line. It cannot be a non-vertical line. And I'm trying to do this as straight as possible. But I get this line here. And now if I look at my intercepts, I have an x-intercept at the point -2, 0. So I'm going to label my graph -2, 0. And my y-intercept, well, it doesn't cross my y-axis. So there is no y-intercept. All right, and so that's vertical and horizontal lines. You get the form and you'll be able to graph them. The last thing I want to talk about is actually interpreting what the x and y intercepts mean in the context of a problem. All right, and in this example, it reads, Marcy owed $6,000 in student loans. She agreed to have $400 deducted from each month's paycheck until her loans were paid off. The amount of money, which is given by your variable y, that Marcy owes after X months have passed, is given by the equation y equals 6,000 minus 400x. We want to find the x and the y-intercepts and explain what they represent, all right? And so one thing that's always very, very important is to know what each of your variables mean, and they give it to us explicitly in the problem. X equals the months. And y equals the amount of money, So I'm going to kind of abbreviate it, right? So that's what these things mean in the context of this problem. She's borrowed money for student loans. She's paying it back. X is the amount of money she has left. Y is the amount of money she owes, all right? And so what I'm going to do is I'm going to start by finding my X-Intercept. All right, again, I'm abbreviating with X-Int. Remember, to find your X-Intercept, you let 0 be substituted in for Y. So I get 0 equals 6,000 minus 400X. All right, and I'm getting this equation from here because this models her situation. All right, remember, I want to solve for X. So what I'm going to do first is I'm going to subtract 6,000 from both sides because I've got to get X on one side by itself. So I get negative 6,000 equals negative 400X. Well, I'm going to divide both sides by negative 400. And so when we simplify this, we're going to get that X equals 15. Okay? And so what I want to do, and as an ordered pair, it'll be the point 15, 0, but that's not so important. What I want to do is I know that X is 15, and I want to interpret what that means in the context of this problem. All right, and if we go back to where our problem is giving our variables, right? X is the amount of money, sorry, not the amount of money. Y is the amount of money that Marcy owes after X months have passed. And what we got as our X-Intercept is that X is 15. Now, notice here that what we did to find that 15 was we put 0 in for Y, right? So this means, remember, Y means the amount of money that she owes. So when I say that she owes $0, it takes X amount of months, 15 months. So basically, to interpret this is that it takes 15 months to pay off the loans. All right, and so that's what this means in the context of the problem, right? We had to use the fact that we put in 0 for Y in order to make that interpretation. Now I'm going to go and I'm going to find my Y-intercept, and I'll do it off to the side over here, right? So to find our Y-intercept, we let Y be 0. Sorry, we let X be 0, and we solve for Y. All right, so I get Y equals 6,000 minus 400 times 0. Right? Well, 400 times 0 is just 0, so we get Y equals 6,000. Again, we can write this as an ordered pair. It would be the point 0, 6,000, since we put 0 in for X, and we got a Y value of 6,000. All right, notice once again here that we put 0 in for X. All right, and remember, X represented the number of months that have passed, and Y represents the amount of money that she owes. So this means, right, well, after 0 years have passed, she owes $6,000, right? Well, that just means, hey, she originally owed $6,000. All right, and so what the Y-intercept tells us is the original or the initial amount or the initial value of whatever of our variable Y. All right, but that's the interpretation of our X and our Y-intercepts, and that is going to conclude this video.